Welcome back, everybody. Today we're talking about rational versus irrational numbers. Now, just go give real quick definitions of each one. Rational numbers can be written as a fraction. I like to say rational rhymes with the word fractional. Any number that you can write as a fraction is a rational number. So think about all the numbers that can be written as fractions. We obviously have fractions. Most decimals can. You can write whole numbers as fractions, like the number 5 can be written as 5 over 1. 13 can be written as 13 over 1. And then there are these irrational numbers, and they're kind of weird. Got a description here for them. Non-repeating decimals that go on forever. Alright, so here's a few examples of irrational numbers. The number pi. We normally abbreviate pi 3.14, but it is considered an irrational number that the decimals go on forever in a non-repeating pattern. Lots of numbers in the square root family. So square root of 2, square root of 3. If you plug those numbers in on your calculator, you're going to see that they are non-repeating decimals that go on forever. Square root of 6, square root of 10, numbers like that. Now, notice some square root numbers, like the square root of 1, the square root of 4, the square root of 9, and so on. Those are not irrationals. Those are all rationals, because the square root of 1 is 1, square root of 4 is 2, square root of 9 is 3. And I can write each of those numbers as a fraction over 1. So not all square root numbers are irrational. Alright, so today we're just focusing on just classifying. Alright, so let's look at a few examples here. It says, which numbers are irrational? Alright, well, real easy way to do this is just plug them in on your calculators, each one. Turns out 3 of these are irrational and 2 of them are not. The square root of 49, that turns into 7. Square root of 64 is 8. So those are whole numbers that can be written over 1, making them rational. Put R for rational. But the irrational ones are A, B, and E. Alright, if you plug those in on a calculator, you come up with non-repeating decimals that just go on forever. In fact, most calculators, especially on your cell phone app or whatever, they're going to cut off the digits because it'll fill up as many digits as it can, but there's just not enough room. You can just go on and on and on. Alright, let's look at another set here. Which numbers are rational? This time we're asking for which numbers are rational, as in you can write them as a fraction. 0.144. Can write that as 144 over 1,000. It's in the thousands place, and that does reduce, but the fact is we wrote it as a fraction. The square root of 0.144. Plug that in and it's a decimal, you get 0.379473192, on and on forever. So this one's rational, this one's irrational. And now we're going to check out that last one, the square root of 0.0144. If I plug that in a calculator, I get 0.12. It terminates, the decimal stops, and then we can write that, of course, as 12 over 100, which reduces. But it is a rational number. So A and C here are our rational examples. Look at another set here. Which of these numbers are irrational? Just pay attention to the question, irrational. Alright, well there's pi right away. Non-repeating decimal, that's our irrational. That's going to answer the question. C is 1.33. That can be written as 1 and 33 over 100. And of course, we can write it as an improper fraction as well, 133 over 100. And then let's see about D. Square root of 196, I want to say 196 is a perfect square. If you plug that in on the calculator, you get 14. So that would make D rational. But then the original one, letter A, square root of 20, 4.472135954999 forever and ever. That would make this irrational. There we go. So A and B are irrationals, with C and D turns out to be rational. Hope this clears up the difference between rational and irrational numbers. Thank you for watching.